Hello. So in this video, we are covering the context part of the function context. So remember when we sort of introduced functions as this sort of aspect of relations, we said that functions have to have this context that's attached to them. So in particular, we're going to be talking about domains, codomains, and ranges. That's going to be the goal, okay? So as mentioned, starting with our definitions. So domain, these are the sort of set of allowed inputs. So what I mean by that, we're going to sort of dive in, but this is very particular word choice that we're using here, right? So I really want to make sure that you're very careful when you look at the actual wording we're using. So when we look at codomain, so this is the set of, the set containing all possible outputs. So when we think about a function, we think of the input, we think of an output, and the codomain is something that contains all those outputs. What do we call those? Well, those things form what we call the range, right? So we have the range, the set of all possible outputs, the codomain, set containing all of those things, and the domain, the set of all things that we can put in, okay? Again, I want to be very clear here that there's some nuanced word choice happening here that we're going to sort of come back to and point out as we go. Now, before we sort of jump in with an example and see this thing in action, it's actually helpful to sort of see sort of an abstract diagram. So mathematicians have this thing that we lovingly call a potato diagram. We'll see this coming up again and again and again. However, since I don't have to draw it, it will look less like a potato and more like a cloud. So I'm going to maybe nickname this cloud diagram at the moment. So we have our domain, this sort of blob of stuff, right? This set of things. We have our codomain, another blob of stuff, right? So we have one set of things that's the input, one set of things that's the output. The input, we usually think of this as like an x, right? And then we put that x into a function like f, and out comes some y value, right? The output. This is sort of how we typically have thought about this in the past. But where the output lands, the actual thing that you get out, that is what the range is. So historically, probably to this point, you probably haven't drawn a lot of differences between range and codomain. In fact, you may not have even encountered the word codomain in previous math classes because a lot of the times these things get sort of conflated. They get sort of mashed into one thing. So part of the point of this video is to really understand the differences between those two things, okay? So to that end, let's think of an example. So let's say we have a vending machine, right? Standard vending machine has a bunch of drinks in it, right? We have our Gatorade bits, right? We have the Pepsi, some other forms of Pepsi, maybe Diet Pepsi or whatever, Crush, like orange soda stuff, water, right? Different things. Now, along with, right, the vending machine, you also have the pad, right? So you're going to have the parts that you can plug in, right? You have your like A, B, C, D, E, and then you have numbers, right? Like 1 through 0. And you plug in the letter and the number, you get the corresponding drink. Not, telling you anything you have never heard before, right? Standard vending machine. Okay. So if we have that sort of set of inputs, well, on our pad, right, we have A through E and we have 1 through 0, but not all of those combinations work, right? So for example, if I were to put in like B, right, I would only have 1 through 4. If I put in like B7, the machine would be like, what are you doing, right? This is not an actual input that we can have. So we only have certain ones that are sort of allowed, right? And that's all of these A1 through A4, B1 through B4, et cetera, et cetera. Now, sort of the next part of it, right, is you have certain drinks you can get out. So you can get the Gatorade, the Pepsi, the Diet Pepsi, the Crush, the water. These are your options, right? So when you're looking at the domain and the range, the domain is the stuff that's allowed to go in, A1 through A4, E1 through E4, et cetera. The range is the stuff you can get out, the different drinks. So in particular, the range is specifically, right, Gatorade, Pepsi, Diet Pepsi, the stuff that's in the machine. But, right, we still have that codomain bit. The codomain in this case, we would say is, say, drinks. This is because the codomain, its real job is not necessarily just to be the actual part that is sort of the specific objects, right? We said it was a set containing the possible outputs. I could say that the codomain is Gatorade, Pepsi, Diet Pepsi, Crush, water. I could say that. But sort of really what the codomain is it's really describing the type of thing that you're getting as an output. So rather than using sort of the actual specific information, you want to pick something that describes the output. So in this case, we're getting a drink out. It's a drink vending machine. So that's why we have a codomain of drinks, right? So it's the type of thing that you're getting. Okay, so we saw that the domain is the set of allowed inputs, but really that was sort of a key sort of phrasing, right? It's the allowed thing. So if we tried to put in something that didn't work, we couldn't use it. So it's sort of simultaneously the thing we have control over, the thing we get to decide, but it also has to be sort of valid. It has to make sense to try to put it in, right? The range was the stuff that we got out again, right? The actual things we got out, the name of the drink. And then the codomain was this thing that sort of described the output, right? So the codomain, a set containing all possible outputs, this is sort of the official definition, but a sort of more intuitive, more useful definition is that the codomain is the type of thing being output, drinks, right? And again, the range being the set of all the specific outputs, that's the key, right? So domain, allowed, range, the actual possible outputs, but all we really need with the codomain is that it's containing all the possible outputs. Now, there's another nuanced word choice here that's really easy to overlook that I also want to draw your attention to, which is that the domain, the set, range, the set, codomain, a set. So this is actually important because the domain and the range, these are fixed things, right? You sort of decide what the domain is, and that's what it is. It is that thing only, that exact thing, nothing else. And then the range is sort of dictated by that, right? Like what you can get out, that is whatever it is. It's a very specific thing. But when we're talking about like a set that is the type of thing you get out, well, I could say drinks like we did, but I could have also said like, you know, Pepsi company products, right? If I had the right kind of water or whatever. That would have been a equally acceptable codomain. I could also have just listed the actual drinks in the machine. That would have also technically been an okay codomain. It would have satisfied the definition. So the important takeaway here is that although domain and range are very specific, very fixed things, right? There's only one right answer for each of those. Codomain could be all kinds of stuff. We usually tend to try to pick something that's like the easiest thing to describe, which is why we sort of default to drinks when we're talking about our vending machine here, because that's sort of the most succinct thing that we could say. It's really a mouthful to be like Pepsi Cola Company drinks or whatever. That's crazy talk. So, the choice that you make is sort of, there's usually a natural option, but there's a lot of different possibilities and they're all fine. Okay, so that's the takeaway. Codomain, not unique. So let's go back to our example here. Let's say that we have the same vending machine here, but for whatever reason, all the water is gone, right? So, a bunch of people came by that were thirsty, took all the water. Well, returning to our domain, our allowed inputs here, well, now if I try to use any of the E level, right, E1 through E4, any of those things, the machine would say, we don't have any of that in stock, right? Out of stock, pick again. So suddenly these things are not allowed inputs. So even though they're in the machine, they are not allowed inputs, which means they're no longer part of the domain. Moreover, because there's no water in the machine, water is no longer part of the range. You can't get water out, so it's not a member of the range, okay? So our domain and our range, these can be impacted in this way, right? If I can't put in the input, then it's no longer in the domain. If I can't get it back out for whatever reason, it's no longer in the range. But codomain, I could still call them drinks, right? Because drinks still describe what's in here. So codomain doesn't have to change even if we sort of change the domain, which then changes the range, okay? So again, back to our definitions here. We have the domain, set of allowed inputs, range, set of all possible outputs. These things are unique, meaning that they are one thing. There's one right answer for each of these. And codomain, it's not unique. There's lots of quote-unquote right answers, but the sort of best way of thinking about this is that it's the type of thing that you're getting out. Okay, so there's one more sort of, I will say, unofficial definition, because this is sort of one of those colloquial things you run into, and that's what is a natural domain. So to sort of really dig into that part, let's think of a more sort of typical equation, right, instead of a vending machine. Now, I could give you our equation here, y equals x cubed minus 3. Now, if I just gave you this, right, remember, we don't necessarily know what is the input and what is the output, right? Sort of by default, we would expect the y to be the output, the dependent variable, the x to be the independent variable, but I'm crafty and mean, so maybe I would reverse those just to be spiteful. But for the sake of this video, we're indeed going to go with y being dependent, x being independent, right? So we're putting in the x value, getting out the y value. Now, the natural domain, this is basically the sort of obvious domain to use if you don't have one given to you. And typically the way that we build a natural domain is we just sort of say, okay, what's sort of the biggest thing the biggest set we could use where all of those things work. So essentially what we really want to do is, what are all the numbers that I could plug into this and have it work, okay? So in this case, the natural domain is all real numbers, because any real number I pick, 5, pi, 27, -3, whatever, I could plug it in as the x, I could cube it, it would work, I would get some sort of y value as an output, right? So all my real numbers are perfectly easy to cube, so that's my natural domain. Then, if I want to know, say, the codomain, my question would be, okay, again, I need technically a set that includes all the outputs, but a better idea would be like, okay, what is the type of thing that I'm getting when I plug in a real number? Well, I'm going to get a real number back, right? That's the type of number I'm going to get, some real number. But it turns out, and I want to make a bit of a distinction here, but it turns out the range really is all the real numbers. I can get all of them. A good sort of natural question to ask is, how do I know that? And the answer is deep, dark magic, at least for now. You don't need to know how we do this now. We're actually going to talk about this more in polynomials sort of specifically, but it's not a thing that you're going to have to do or expected to do at this point in the course. So don't worry about knowing the actual range yet, like computing a range given some domain or whatever. That's a whole other thing we're going to tackle later. So the takeaway, though, here is just taking on faith for the moment that your range happens to be all real numbers. So if we have our natural domain, the biggest domain we can choose, codomain and range. In contrast, I could give some other domain, right? Like the natural domain is what you use when you don't have one. But I could give you a stated domain, like I'm only going to put in numbers from -1 to 1, okay? So if that's sort of what I've told you is the input, that's the domain. Whether I could put in other numbers or not is irrelevant, right? That's the one I'm just giving you to start with. My codomain here, though, doesn't need to change, just like with our vending machine example. Any sort of output is still going to be a real number. My codomain is really just there to describe what I'm getting, so it's a real number. That's my codomain. But because I'm sort of shrinking what I'm allowed to put in, right? You can think of this as sort of the action and the range is the consequence, right? So when I plug in a value, I get a value out. So if I decide to shrink what I plug in, my range will get correspondingly smaller. So that means that here, again, to be very clear, you don't have to know how I got this yet. We'll talk about this later. But here, my range is not all real numbers anymore. Now it's -4 to 2. Right? So my stated domain, if I give an artificial domain or a stated domain, this thing is usually used to sort of restrict what the output can be, right? So these things are linked together, and that's sort of an important takeaway here. So natural domains, these things are sort of what we use when we aren't given one, and it's just sort of the biggest one that makes sense, okay? All right, so what do we do? So we know functions, right, are these sort of relations with a special sort of part to it, right, a special rule attached to it. But what makes a function sort of a function instead of a relation most of the time is this context, right? They require context. And in math language, that context is the domain, codomain, and range. So domain, that's the input, this thing you probably have run into before. The codomain and range, you may or may not have heard the word codomain, but the codomain is the type of thing you get out. The range is the actual list of things you get out. And then sort of depending on the situation, you may or may not be given like an explicit domain, right? Like here's a function and here's the exact values you're allowed to use. If you're not given it, it's sort of assumed to use as many as possible. And that's the natural domain. So the natural domain is sort of the biggest possible set that makes sense versus a stated or artificial domain, which is what it's sort of presented to you when you're given the problem or given the original function. Okay? So that is that.